In this question, we are given a 2D array, and in this 2D array, a cell has either plus sign or a dot sign. A plus sign means it has a wall, it is a wall, and dot sign means it's an empty cell. What we are supposed to do is we are supposed to return the number of steps in the shortest part from the entrance to the nearest exit. So we have an entrance given 1 comma 2. So this person entered at row 1 in the column 2 in this cell. We have to find the nearest exit for this person. So an exit can be either this location, or this location. But since this person can't reach this lower bottom cell because it's surrounded by walls, we are left with two options, this one and this one. They can reach both these exits, but obviously the shortest one is the one above them. So how we can solve this question? We can solve this question using queue. What we will do is we will start with this cell in the queue, and we will move in all the four directions: left, right, up, and down. And for each direction, we will try to find out if it's in bounds, and if it's in bounds, is it plus or minus dot. If it's an empty cell, only then we will move to that visit that cell, and we will keep on visiting all four directions from these cells as well. So if we move to the left cell, we'll move in the left direction, up direction, right direction, and bottom direction for this particular cell as well. And if we move in the top direction, we'll again do left, right, down, and up. But in this case, obviously this cell above the person is an exit, so we will return the number of steps we have taken until now. First of all, we will initialize a queue, and in this queue we will append the cells we want to visit. Queue.append. We'll append a tuple, entrance 0, entrance 1, and also the number of steps we have taken until now to reach this cell. Since we just started at this cell, we will add 0 as the number of steps taken. And also all the cells that we append to queue, we want to change the symbol from dot to plus, so that we don't add them to the queue again in the future. If we do now do this, we will end up in an infinite loop, and we will keep adding the cells that we have already added to the queue again and again. Now how we can do that is we can write maze entrance 0, entrance 1 equal to plus sign. Now while queue, what we will do is we will keep popping the element from the queue and traverse in all four directions: left, right, up, down. And for each direction we will check if it's in bounds, if it's an exit, if it's an exit, if it's an inbound, if it's an empty cell, or if it's a wall, and we will handle each of these cases in a proper way. So first of all, we will pop the element tuple from the queue, current R, current C, current steps will be equal to queue.pop left. So now what we'll do is we have this current cell. We will traverse in all four directions for this particular cell. So for dir in, we'll traverse in right, left, up, and down. So for right we can write 1 comma 0, for left we can write -1 comma 0, for in the upper direction we can write -1 comma 0, 0 comma -1, and for the bottom direction, down direction, we can write 0 comma 1. And so for all these directions we will calculate the new coordinates. nrnc is equal to current R plus dir 0 comma current C plus dir 1. Once we have calculated the new coordinates, we want to check if they are inbounds. So for that, if nr is greater than or equal to 0, less than len maze, and similarly if nc is greater than or equal to 0, I don't know what I am doing right now, 0, and nc is greater than or equal to 0 and less than len maze 0. if it's an inbounds, and if it is, and if maze nr nc is equal to 1. If it's an empty cell only, then we want to deal with it, otherwise we will just skip it if it's a wall. Now if it's an exit, so for exit it has to be either a first cell, or it has to be a first row, last row, or it has to be a first column or the last column. If it is an exit cell, we will just return the number of steps we have taken until now plus 1. But if it's not an exit cell and it's an inbounds, and if it's an empty cell, so what we will do is we will append it to the queue dot append nr comma nc comma current steps plus 1. So current steps plus 1 is the number of steps we took to reach to this particular cell. And also, as I said, we will change the sign to plus so that we don't add it again to the queue in future and end up in a time error. Now if we are not able to find the exit in this while loop and the queue is empty now, we can be sure that this person cannot exit the maze. Wrong error, not sure why. Let's check our code. So we are initializing a queue, we are appending the entrance 0, entrance 1 and steps taken to the queue. We are setting entrance 0, entrance 1 cell equal to plus. While queue, we are also popping the elements from the queue for the dir in 1 comma 0, right direction, left direction, but top direction, up direction, down direction. Okay, nr comma nrc is dir 0 current c plus dir1. That's correct. If nr is less than len maze, if nc is less than len maze 0 and maze nr nc is equal to dot sign. If nr is equal to 0 len maze or nrc is equal to, oh yeah, it should be minus 1. Yeah, sometimes we make silly mistakes. Thank you for watching this video. Please consider subscribing to my channel.